Our topic today is on equilibrium of forces. The first thing is to first of all define the equilibrium of forces, and I would like to define it in two ways. The first one is that a body is said to be in equilibrium if it is at rest, that is not moving, or moving with uniform speed on a straight line. Once again, a body is said to be in equilibrium if it is at rest or moving with uniform speed on a straight line. The second way of defining it is that you can say a body is said to be in equilibrium if it is not rotating or rotating with uniform angular velocity. Or if a body is said to be in equilibrium if it is not rotating or rotating with uniform angular speed. Now, from the definition, you can see that a body can be at rest like this. We say it is what? In equilibrium. Why? Because downward forces is equal to upward forces. Then, a body can as well move in and be in a state of equilibrium. In that case, it will move with uniform velocity. That it will not accelerate. Therefore, the force in that body, let's say we have a car, moving with what? Uniform velocity. So in that case, the force in the engine that's pushing it forward must be equal to what? The frictional force that's pushing it back. So the car will not accelerate. Now, that will now lead us to different force by which a body can be in a state of equilibrium. The first one is when we have two bodies and they have the same temperature. We have body A and body B. If they have equal temperature, and we can say they are what? They are in a state of thermal equilibrium. Thermal equilibrium. Then another one is when the body is moving and it's moving with uniform velocity, that is not accelerating. So we can say the body is in a state of what? Kinetic equilibrium. The body can be static. So we say it's what? It is in a state of what? Static equilibrium. In that case, downward force will be equal to what? Upward force. And if you look at something from the explanation so far, you know that we are mentioning equal, and you can trace the element of that from the topic, equilibrium, from equal. Now, let's go on. We cannot discuss about equilibrium of forces without mentioning resultant of force, which we have done in our previous topic. When we say resultant, don't forget, it's a single force that will have the same effect, both in magnitude and direction, as other forces acting together or adding together. Now, just like when you have this, so we have this force A or force 1, then force 2 acting on this body. You find the resultant of this like this. This is the resultant. Assuming our resultant is 20 Newton. Good. The resultant of this and this. So it means the force that's acting on this body is 20 Newton, pushing it in this direction. Then, if we now want this body to be in a state of equilibrium, that is, we don't want it to move, it means we need another force that will act in opposite direction to this, like this. That force must have the same magnitude with this, that is 20 Newton as well, but just that it's acting in opposite direction. Then this one is now called equilibrium of forces. So if you are asked to define equilibrium of forces, it's also a single force having the same magnitude with the resultant, but acting in opposite direction with what? The resultant. Once again, the equilibrium of forces is a single force having the same magnitude with resultant force, but acting in opposite direction with what? Resultant force. Now let's go to another subtopic, that is equilibriums of three forces. That is, under what condition would three forces be in a state of equilibrium? For instance, when you have, let's say we have a bucket of water like this, somebody is holding it here with certain force, another person is applying force here, and the body is not moving. What does that one signify? It means this force acting like this, another one here, then we have another one, the weight of the water itself acting downward. So the three bodies are in state of equilibrium if it is not moving, showing that the resultant of this and this, when you find the resultant of the two forces acting on the bucket, will be in this direction. Then it is equal to the weight of the water. Now, if you are now asked to define or state principles of what? Equilibrium of three forces, triangle of forces. You now say three forces are said to be in equilibrium. Three forces are said to be in equilibrium if they can be represented both in magnitude and direction by the three sides of the triangle. Now, what is the condition? For example, by way three forces to be in equilibrium, the first one is that any of these three forces can act as equilibrium for the others. That is, when you have this one, find the resultant of this and this, like this. This is equilibrium, that's keeping it what? State of equilibrium. When you find the resultant of this and this, it will come in this direction. So this one will serve as what? Equilibrium. When you find the resultant of this and this, it will come in this direction. Then this is what? Equilibrium. Which shows that any of the three forces can serve as the equilibrium for the others. It's a wide question. It asks you, which of the following is not related to a triangle of forces? Now that's first one. The second one is that the three forces must meet at a point. That is, when you trace this one, then trace this. So that three of them will meet at a point. Then another one, the third one, is that these three forces, they represent what? The three sides of a triangle, both magnitude and direction, as it appeared from the word principle. Then, if you now have three forces acting on an object, how will you get the resultant? It's very simple. Even some questions they may ask you to make it to form a triangle. When you have force like this, then like this, then we have this. If this one is F1 and this is F2, this is F3. The first thing is you must know how to find the resultant of unknown from here. They may give you this one, while they will leave this one. You have to calculate this and this, and they will give you angle. Let's say this angle is 130, then this one is 120. So what you just do to get this angle, add this and this together, which will give you 250 degree. Then take 250 degree from 360, you get this one. That's 110. Very simple. After getting all the three angles, you can easily determine what? The unknown force using Lamy theorem. And Lamy theorem says, look at, let's say this one is alpha, this one is beta, and this one is gamma. Apply Lamy theorem. You can start from F1, see, F1 over sine of angle opposite to F1. That is sine alpha is equal to then F2 over sine of angle opposite to F2 sine beta is equal to F3 over sine of angle opposite to F3, that is sine gamma. So out of it, you can use the three at the same time, depend on what and what are given. You can combine this and this together. You can combine this and this together, while you can still combine this and this one together for you to determine your unknown value in the diagram. Now, if you now ask to use it to form a triangle, It's very simple. What you just need to do, when you have this, then you have this one. If this is F1, this is F2, this is F3. If you have the three forces like this, it's very simple to change to what? Triangle of forces. What you just need to do, find the equilibrium of one of the three forces. So I can say, okay, let me find the equilibrium of this one, which will go up like this. So this F1 is here. Then look at the direction of this F3, or you look at the direction of F1, any of the two. If I want to shift this F3, I will come back here, shift it like this, direction like this. You now go like this. That's all. This is F2, this is F1. Then this F3 is one that you transfer to this place. This one will be what? F3. That's all. And you may decide to what? Leave this one. Then draw the line of action of this one, or equilibrium of it, like this. So this one will serve as our F3. Then you can keep this F1. Then look at your F2. So F2 will now come back here like this. In this direction with your ruler. So that you have your F1, F2, F3. F3 is still maintained. So it's very simple. So the next topic, the next topic we are going to do is, and don't forget Elami theorem. Okay. The next one is moment of force. Moment of force from a point is what? Effect, turning effect of force from that point. Once again I said, moment of force from a point can be defined as if turning effect of a force from that particular point. And it can also be defined as what? Product of force and perpendicular distance. Therefore, if I have this object, if I apply force on it like this, so this is where the object will be turning. They are raising it up like this. This is turning point. So this from here to here will now serve as our perpendicular distance. So this is the force F. Therefore, moment of force P is equal to force, product of force, multiplied by perpendicular distance D. But what of if the force is not perpendicular? Therefore, I would like to assume that the force is applied like this. If the force is applied in this direction, and you want to calculate moment of force, it is wrong if you apply it like this, because this distance you apply here is not perpendicular to this line. It's wrong. So the next thing is to look for what? A line that will be perpendicular to this line of action of the force. So in that case, you draw the line of action of this force like this. Then draw a line from this one that will make a perpendicular to this line. So you can just draw it like this. Use your protractor to measure it and make sure that this place is what? 90. So in that case, this is what? Perpendicular distance you need. Let's call it X. So in that case, you look for this line. Find means of getting this line. If the angle of inclination is given to be theta, you transfer it here. Vertically opposite angle are equal. So in that case, we have opposite. We are looking for opposite. Hypotenuse is given. You now say sine theta is equal to opposite x over hypotenuse d. Then make this x the subject of formula. Therefore, our x is equal to d sine theta. Therefore, where we need this d, that is moment P is equal to force times d. And this d is not perpendicular. What perpendicular is x? So it's supposed to be moment of force is equal to F multiplied by x. Then our x will be replaced with what? D sine theta. Therefore, we have what? Moment of force is equal to F multiplied by